two very common properties which will help you with your own math, but will also appear on tests that you'll need to be able to identify, are called the associative properties. One is the associative property of multiplication, and the other is the associative property of addition. Let's start with the associative property of addition. To associate, first of all, means to connect to something or someone, especially in your mind. You can make a connection between them. It also means who you associate with is who you hang out with, who you group yourself with. So when you hear the word associate, I want you to think about who you're hanging out with, who you're grouped with. In the associative property of addition, here I have SpongeBob, and in his neighborhood, he associates with Squidward. They see each other around their street, they live right next door to each other, they're grouped together. And Mr. Krabs does not live near SpongeBob and Squidward. But when they're at work, SpongeBob and Mr. Krabs are together all the time. They work together, they see each other all day, they're in the same room or the same building. Squidward, not so much. He doesn't work at the Krabby Patty. He maybe comes in once or twice, but he doesn't work there. He's not with SpongeBob and Mr. Krabs all day. The associative property of addition means that if you are looking at only addition throughout your entire problem, it doesn't matter which group you put SpongeBob in. If you put him with Mr. Krabs, if you put him with Squidward, or even if you put Mr. Krabs and Squidward grouped together and SpongeBob off to the side. You are still going to end up with SpongeBob, Mr. Krabs, and Squidward. Doesn't matter how you add them together, they'll all three still be there. So let's try that with some numbers now. If I have a group of 5 plus 4, and then I add on 15, well, order of operations tells me 5 plus 4 is 9, plus 15 is 24. Now, I could just have easily have done my groupings another way. I could have switched it up and said 5 plus 4 plus 15. Now I'm doing my order of operations inside my grouping symbol. That is 19 plus 5, which still gives me 24. Another strategy I can use is even more creative. I don't have to put grouping symbols in there if I don't want to, but I also don't need to keep the order of 5, 4, 15. I know that 5 and 15 added together will make me a much friendlier number. 5 plus 15 is 20. Plus 4, that's a lot easier for me to do in my head than 19 plus 5 or 9 plus 15. 20 plus 4, I can pretty quickly say, oh yeah, my answer is 24. So you don't even need to keep the order that the original problem was in. If it's all addition, you can flip things around to make yourself friendlier numbers, to make you more confident in your answer, and also to make that mental math go faster. Let's try another one. Here I have 10 plus 17 plus 20. I could just add from the beginning and say 10 plus 17 equals 27 plus 20, or I could rearrange and say, hey, 10 plus 20 plus 17, 10 plus 20 looks to me like that's going to be 30, plus 17, that's 47. A bit faster. In this case, it didn't maybe save you so much time, but when you get to harder and harder problems, rearranging your addition problems can make your work a lot easier. Now, this property works for addition, and it also works for multiplication. Let's try it with multiplication. I can solve the way it's written. 5 times 10 is 50, times 5 is 250. Or, if I'd rather, I can regroup and rewrite my original problem. 5 times 5 times 10, I can get the 5 times 5 out of the way. 25 times 10, I know 25 times 1 is 25, with a 0 on the end, 250. might have been a little bit faster. Let's try another one. I have 2 times 19 times 5. Okay? If I just look at it in order that it's already there, 2 times 19 is 38 times 5. Ooh, okay, take it over to the side. 38 times 5, stack it. 5 times 8 is 40, carry your 4. 5 times 3 is 15, plus 4 is 19. Okay, my answer should be 190. Okay, it didn't take me too long, but maybe if I'm rushing and it's my very last question, I could have made my life a little easier by saying, oh hey, 2 times 5 times 19. 2 times 5 is 10. Times 19, well, 19 times 1 is 19 with a 0 at the end, 190. Oh look, I didn't even need to do all that work. If I reordered my problem and made some friendlier numbers for me, I could find my answer a lot faster. Does the associative property, not the multiplicative, does the associative property work for division? If I say 10 divided by 2 divided by 5, what's that going to be? 10 divided by 2 is 5. Divided by 5 is 1. Can I rearrange that and say 5 divided by 10 divided by 2? Well, let's see. 5 divided by 10 is 1/2. 1/2 divided by 2 is keep, change, flip. 1/4 versus 1. Not the same answers. There is no such thing as an associative property of division because order matters in division. It doesn't matter in multiplication or addition. What about subtraction? 10 minus 2 minus 5. 10 minus 2 is 8. Minus 5 is 3. 5 minus 10 minus 2. Can I switch the order around in an associative property of subtraction? 5 minus 10 is -5. Minus 2, -5. Keep, change, opposite. Add those two together, that's -7 versus +3. Whoa, definitely not the same answer. There is no such thing as the associative property of subtraction because just like division, order matters in subtraction. It does not matter in addition and multiplication, which is why I can change around the order and have an associative property of multiplication, and I can change around the order of an addition problem and have an associative property of addition, but no division, no subtraction.